Okay, so again, thank you very much, the BINUS. I'm happy to be here for the first time for the Global Learning program. So the topic that I chose is matrices in our daily life. And I'm sure that everyone has learned about the matrix, right? In your classes, probably last few lectures, but I will touch a little bit about matrices. Okay, but before that, how many of you have been to Malaysia? Yeah? Okay, you can just raise your hand. Oh, good. You have not been to Malaysia? But it's okay. I'm here now in Johor Bahru. Okay? And you are somewhere here, right? In Indonesia. Where is actually BINUS? Jakarta? Or you have in many cities? Pak Faisal? Ah, I can see someone. Ah, okay, okay. That's good, that's good. Okay, I give you A for the map. All right, so I hope that one day, maybe you can come and visit us in University Technology Malaysia. Yeah, okay. Okay, you can you can undo. Okay, all right. Okay, so this is Malaysia, right? This is what we call Peninsular Malaysia, and this is East Malaysia. Okay, we have 13 states. So I'm here in Johor, and the city is Johor Bahru. Okay, maybe you have come to KL. So we have two campuses, one in KL and one, the big one, main campus in Johor Bahru, right? And we are actually here just across Singapore. So you can fly to Singapore and then you can cross by train or by bus or by cab. Actually, you can walk along this bridge over there. Or you can fly to KL and then you can go down to Johor. Okay, there are two ways. Now, this is my background. I just want to share. I graduated from this university for all my degrees. And I've been working in UTM since after my master. Since 1991, I work in UTM. So now it's 32 years plus this year. Okay, you have learned about matrix. Okay. Who do this to my screen? You can undo. Who introduced matrices? Arthur Kelly is an English mathematician who introduced the matrix formula in 1859, so long ago. And it is first used to solve linear equation. So I think in linear algebra, we have learned about matrix, right? In the first chapter, and normally, and linear equation, all right? Now, what is a matrix? Yeah, what is a matrix? So a matrix normally we draw as the rectangular, or sometimes we draw as a bracket. Yeah, so this, we draw this, right? Or parenthesis, the circle one. And we have M rows. These are the rows. First row, second row until the M row, and the column. First column, second column until the N column. I think everyone knows this already, right? So this is a matrix of M by N, right? This is in arrangement. And elements inside, in Malay, we call it entry is unsur, right? So depending on what you use and how you learn this, but it's the entry or the elements in the matrix. So in M by N matrix, you will have M times N elements. So if you have like 3 by 2, so there will be 6 elements inside the matrix. Now, why do we learn matrix? Okay, and why computer science students need to take linear algebra, and you also have to take discrete mathematics in linear algebra. Why? So we are here today to see not only computer scientists or mathematicians, but many others need to use matrix. So the first one is to solve simultaneous equation, right? And the equation that we learn doesn't need to be the same number of equations. You see this equation, 2 equations and 2 unknowns, right? X and Y. So it doesn't have to be the same. Just now we say you can have M rows and N columns. So M need not be to be the same with N. You can still solve any linear equation. So this is the use of a matrix in which you see the coefficient, -4, -3, 5, and 4. So this becomes the matrix. When we multiply by the variable xy, you get the 1 equal to, which is 32 and 25. I think all of you know how to multiply, right? This is 2 by 2, multiplied by 2 by 1. So -4x plus 5y is 32, exactly like this. So from a linear equation, you can write as matrix times a vector. And there are 3 ways, right, or more, how to solve for x and y. So you can just reduce variable, or you can do operation, right? Or here, I show the inverse method. I think you also have learned this, right? XY is the inverse of this matrix. So you find the determinant, right? 1 over AD, which is AD, minus BC, right? The determinant. Then you multiply by the adjoint, right? And then 32 and 25, multiply out, then you get x and y right away. But this one only if you have m equals n. This is I'm just showing one way to solve a linear equation. Now, you also have learned types of matrices, right? Type of matrices, identity matrix. Identity matrix, if we write as a matrix Aij, it's a square. So m equals n is a square. So we just write n instead of n by n. You can just write n. So I can say I4. This is I4. So this means the entry is always either 1 or 0. And the entry is 1 if the row equal to the column. If the row equal to the column, A11, A22, A33, A44 means the diagonal. So all diagonals are 1 and the rest is all 0. So this is what we call identity matrix. Why we call it identity? Anyone wants to answer? You can write in the chat. Yeah, just now is Cramer's rule. Very good. Why it is called identity matrix? Because it does not transform the basis vector. Okay, it's called identity because when you multiply any matrix with the identity matrix, you get that matrix back. It doesn't change. That's why we call it identity. So A times I is A. Left or right, I times A is also A. Yeah, I know that is what you meant. Okay, meaning you don't change the original. Okay, so identity matrix has to be a square. Now, what is symmetric matrix? Symmetric matrix, later on, you will see the use of it in many problems. Symmetric. Symmetric means B and B transpose is the same. What is transpose? Transpose means you write the column as a row, right? So you look at the first row, 3, 2, -5. The first column is also 3, 2, -5. So every row is equal to the column, or you can draw a mirror here. Draw a mirror here and flip, right? Flip at the diagonal. and you can see that they are equal entry. 2 equals 2, -3 equals -3, 1 equals 1. So there are two ways to look at it. One is the row is equal to the column. The other one is you put like a mirror in the diagonal, and you can flip, then the entry are the same. Okay, next is diagonal matrix. Is defined to be only the diagonal has non-zero entries, if there is. Okay, diagonal can be all zero, but if there is a non-zero, it's on the diagonal. That is what diagonal matrix. It can be zero, but if it's not zero, like a 2, like a 1, is on the diagonal, also square. Yeah. And zero matrix, as what it is called, is all zeros inside. Zero matrix can be m by n, doesn't have to be square. It can be like 3 by 2, right? Or 3 by 3. That's for zero matrix. Diagonal matrix has to be a square. Otherwise, how can you find the diagonal, right? Symmetric matrix also has to be square, like identity. Okay, I mentioned about transpose. Yeah, so the transpose, the first row, A1, 1, 1, 2 until 1n is this first column. So first row becomes first column. Second row becomes second column. And the inverse, you learn about this too, right? A matrix is called inverse if, when you multiply, it is equal to the identity matrix. And it has to be square, right? Because not only you multiply on the right, you have to also be able to multiply on the left. Okay, so that's why you have to have a square for a matrix that has an inverse. And this is the formula. I think you have also learned about how to find the inverse of a matrix. Okay. It's just still introduction to matrices. Yeah. I have not gone into the application yet. And you know now matrix operation, right? How do you add two matrices? You have to have the same dimension, then you can add. And when you add, it is the same entry, right? You add. Multiply, I think you know how to multiply a matrix, and subtract. Subtracting a matrix means you add the -1, right? This is also okay. Now we want to see the usage of matrices. This is just 4 among so many usage of matrices. So you can see the usage of course, computer science, because computer science students have to take linear algebra, right? And I will share a little bit on the usage of matrices in chemistry and also physics and also accounting. Okay, now in computer science, I am not going into the detail of this. You can right now you can ask Mr. Google, right? In Adobe Photoshop, they use matrix to process linear transformation and produce pictures. You know, you also learn about, I don't know if you have learned about linear transformation, is it? Anybody? Chapter 4, after your vector space, right? You will learn about linear transformation. Okay, somebody put in the chat, let me read. Oh, okay. Okay, maybe you have gone through it. So linear transformation is a mapping. Okay, it's a mapping. Like you transpose the face into become something else. You can pull the face to be maybe thinner or fatter, those things. I think we learn Photoshop, right? You have photo, and then you can put somebody else inside. All this actually use matrix to process all the linear transformation. Yeah. So behind the scene, we just use it. But the original one, if you maybe some of you will be writing research, you can look at this closer. Okay, now a lot of the usage of matrices actually in chemistry. Okay, I'm not sure if all of you have taken chemistry, sometimes in high school. In Malaysia, science student will take chemistry. So you have actually in finding the energy of atoms. Later on, I will share some formulas for this one. So energy that you find in molecules, in the atoms, use matrices. They use matrices. This is ethane. Yeah, you have the atom and you have the bond, okay? And from this, actually, you can transfer this to graph. Okay, later on, maybe you will learn about graph. And that is the properties of this molecule that the chemists do it in the lab, but mathematicians can compute on paper. Okay, so this is something that use matrices that I will show you how they will find some of the terms that I will introduce after this. I'll just show this in general first. Okay, I mentioned about energy. Okay, I mentioned about energy. They have thermal energy, they have nuclear energy, chemical energy, gravitational energy, kinetic energy, potential energy. Those are different types of energy, some in chemistry, some in physics. Some particular energy is associated with matrices. Okay, let me show just one example of a usage of matrix in chemistry. Okay, now this is a graph. Okay, oops. Okay, I don't know if you have learned graph, but let me explain. Yeah, this graph is not like sine and cosine. Graph, when I say graph, it means it has vertices and edges. Okay, so look at this graph. There's vertices A, B, A squared B, A cubed, A squared B. This actually has something to do with another set, what I call it group, but I'm not going to go into group. It's just a set, okay? And those elements of the set becomes the vertices, and some of these elements with their own properties becomes the connected, the edges one. Okay, let me show you how the chemists translate the graph into a matrix. They put the vertices on top here. There's vertices. And also down there, the vertices. If two vertices are connected, like this is A squared B, this is A squared B. If they are adjacent like this, you will put number 1. So if these two adjacent, there's one here, there's one here. So you see that this matrix is symmetry. Yeah, this matrix is symmetry. Because if this vertex is adjacent to this vertex, you get 1 in the matrix. This vertex is adjacent to this vertex, right? The same edge, right? So what we call this matrix is adjacency matrix. Now count how many edges. 1, 2, 3, 4, 5, 6, 7, 8, and so on. And the number here, upper triangular, those are how many ones do you see? So when you see ones in the upper triangular, that is the same number of the edges in the graph. Okay, so from a graph to the matrix. Okay, now in last chapter, Pak Faisal, they haven't learned about eigenvalue, right? But I'm gonna just mention there is the what do I call it? the formula for the eigenvalue that you will learn later if you haven't learned. But with this formula and eigenvalue, this is the energy. This is the formula. Okay. The formula of the energy is the sum of the, what do you call this? Modulo, right? The positive value of the eigenvalue. And then you add up the sum. You see this one? 4. And then you have 2 of -2. So you will add the modulus is 2. So 4 plus 2 plus 2 plus 0. So the answer is 8. So this one is the energy of a particular, if you can translate originally from molecule into matrix, and you calculate the eigenvalue, and then you get the formula, sum up the positive value of the eigenvalue, then you get the energy. Okay, so this is how you use a matrix. Okay, matrix is in the middle. All right. Okay. Another way that mathematician is helping the chemist is by finding topological index. Okay, topological indices. Now I have a few PhD students actually doing research on topological indices, and there are so many topological indices available. One of it is the Wiener index that I'm showing over here. You can also have first Zagreb index, second Zagreb index, Harari index, Sombo index, more than 100. There are different types of indices. I'm not going to go into the detail what it means, but some of them give a meaning to a chemistry where this index means this value that you use in the chemistry. Yeah, one of it is like as a boiling point of a certain molecule. Again, you see a graph. Yeah? Again, you see a graph, and from this graph, you have a distance matrix. So although this is a little bit graph theory, but I want to show you only matrices. Maybe later on you will take discrete math. I'm not sure. Normally in UTM, after linear algebra, you will take discrete math, and then you will learn graph theory. Yeah, in one chapter. So you will see that you need linear algebra because in graph theory, that's also related to matrices. What do I mean by a distant matrix? Okay, just now, if they are adjacent, you put 1. In this matrix, you calculate the distance. Like from A to B, I put here A, B, AB, A squared B, A squared. If there is no from A to A squared, this is A, this is A to A, they're all 0, yeah? We don't go from one same vertex to another. If the distance is 2, like from A to A squared, you don't see, right? You don't see any line. So you have to go from A to A squared B, then A squared. Okay? 1, 2. That's why you put 2. If they are adjacent, like from A to B, adjacent from A to AB, adjacent from A to A squared B, adjacent, bersebelahan, you put 1, 1, 1. So this is called the distance matrix. So matrix, right? So from this matrix, when you have the distance matrix, you can calculate the Wiener index. Okay, the Wiener index is 1/2 summation of D, the distance from 2 vertices, from I to J. First, you change the J, and then you change the I. Okay, the distance between 2 vertices. So from molecule has atoms, atoms become vertices, molecules have bonds, bonds becomes edges. So you model the molecule becomes graph. From graph, you create many different kind of matrix. Just now I show you adjacent matrix. This one is a distance matrix, and many other matrices that you can see later on. Okay, then the calculation is quite direct, but if the matrix is big, if you have many vertices, then you will do double summation and it will be a lot. Okay, it run through so many, like this one, 1, 2, 3, 4, 5, 5 times 25. You have to do 25 times and you calculate the distance. Now, if you calculate here, you will get the answer. Okay. Now for physics, if you have taken some physics class, right? You have the one on the left. I still remember when I took this in high school, right? You have this, kita panggil apa? Lita, right? Circuit, right? Circuit. And then you put battery. You put battery and put a bulb, right? Put a bulb mentol where it light up. So you can have parallel circuit, or you can have just the one round. Yeah, not parallel. This one is parallel. And then we learn about R stands, if Malay is rintangan, yeah? And how the electricity comes. And they use also when they learn about laser and when they learn about optics. So physics students in the university, if we have also education, physics education, they have to take linear algebra because they have to know about matrices. And the same thing for science, undergraduate degree in full physics or physics and education. They will learn. I didn't have the detail on how they put matrix in there, but if the one at the end becomes all the dimension of the matrix and then how they connected, so you can actually figure this or model this like graph also. Then from graph, again, you can go to this. The next usage of matrices is in accounting. When you have this data like in rows and in columns, and the entry means something that you can put in the entry, normally will be figures, right? You don't put the entries. How do we calculate matrices if the inside are not numbers, right? So like this one, for example, the commodities, activities, you write the same thing on the row and the same thing on the column. And then there's somehow a total, I didn't put in numbers, but just showing briefly in how they use a kind of matrix in accounting. There's a lot. I took a few actually accounting courses. I can see lots of metrics also. When the inside, like household income and tax, right? They become a range. Sometimes they put a number or average, and then they calculate accordingly to the formula in the accounting. If you've taken some economics courses, you will see also quite a lot of matrices in economics. Yeah, I took some classes in economics. We learn about supply and demand, and within the course of econometrics, in which they use lots of statistics, but also matrices, and also in monetary economics. Yeah, when they have table, and then in the table they have certain entries, which is figures or numbers. This table give like products, some products. So if they represent in terms of metrics, relation between the variables in economics, like this variable is there is some relation to another variable, okay, and they have a figures inside. So they measure this actually, instead of you look at the table, they measure in terms of linear equation. So from the original like production in the firm, they write their problems in terms of linear equation. From linear equation, you remember in the beginning, I write linear equation into the form of matrices. So you do lots of modeling. Okay, modeling means, mathematical modeling means, is the real life, the maybe 3-dimension, and you write in terms of a simple model in mathematics using parameters, variables, equation, or like a table or a matrix, and it becomes something that you can solve using mathematical equation or formula. So we do lots of modeling, whether we don't realize, or every day actually. Okay, so this is economics. For business, for business, now we have, for example, if you are interested to do stock market, okay, stock market, you become very rich. And they use also because when they do, they compare about markets and about product and services. Now, for example, in this part, they have rows, 3 rows, the new market development or new diversification, and then they expand, right? They expand their business or they expand their market. Then they look at the expansion. So you will see the row is new, expanded, and existing market. And then the product that they have also use existing, modified, and new. So from this, inside, I didn't put the detail of the figure, but for example, do you want to use just existing product with existing market? Then probably this is certain amount. Yeah, you want to do existing product, but your market expand, or this one is the best one, right? You want to use or introduce new product in a new market. So that gives you maybe in terms of what they call it, modal. What is modal? You need lots of money, right? I forgot what modal is. Let me see. You have to help me. Capital. Thank you, Daya. Actually, Daya is my PhD student. I asked Daya to join just in case I cannot share the slide. Okay, so you need lots of capital if you need to introduce new product in a new market. So you can put the capital inside. How much? Like millions, right? Ringgit or rupiah. You can put the figures inside. So it means a lot for the businessmen if they use basically how they can make it simpler using matrices. So the usage of matrices in strategic management planning and marketing strategies. Okay. This is also very interesting. Okay, this is also a subject in economics, the subject in economics, which is called game theory. Okay, so many board games. We play board games, but we never know that behind the board games, there are lots of mathematics. Okay, after this, maybe you can try and Google some games. Try to Google game versus mathematics behind the game, something like this. All right. So this is one example. Sometimes some games you need good strategies. Like how many of you play Monopoly? You play Monopoly, right? You have to have good strategies. You don't just like you do the dice and then you stop and then you just buy all the land, all the houses or hotels or what you call it, right? But you have to have good strategies. And you play the cubic, right? The cubic? Okay, the cubic actually, although not really matrices, but it's more to the permutation. Permutation, actually, you can also combine with matrices. When Linda Algebra, you don't learn about permutation, but maybe, yeah, in discrete, you learn about groups and permutation. So in this row, it's either you confess or you don't confess in the column. So this game is about confession, okay? Okay, this is in computer science, in wireless communication. So you have also, you can, this is actually when we have handphone and we have, what is it called? The one that receive the signals, that becomes the vertices, and then the wireless, the internet is the edges actually. And you can also write that as in terms of matrices. So the wireless signals are modeled and optimized using matrices. So optimization is very, very crucial and very important to the firm to save money. Okay, when they have their product, they want to save, so they don't charge so much. Yeah, so matrices are used to detect, extract, and process the information encoded in signals. Also, if you have learned about cryptography, although it's just numbers, it also has relation with matrices. Yeah, so wireless communication. And in engineering, they also learn this. So some engineers, they also use, they don't create the formula, they just use. So the formula comes from the mathematician. Right now, we use a lot of computer and computer graphics. Okay, many of my students, when graduated, they become computer graphics. They not really, well, you think that you just work and play with just numbers, but no. So many go into the computer industries because what they learn, the logic, the thinking, the theory, all behind this, and they write like program. So many use programming, lots of matrices. So in computer graphic, they use the basic about the identity. So matrices are used to project the three-dimensional image. When we take photo, three-dimensional, right? And then they write in two-dimensional plane. How can we take our photo, three-dimensional, and when we take, it becomes a photo, a two-dimensional, right? You will learn also about linear transformation and how do you use actually to translate. Translate means from here, you move here, right? When you draw something, you move. So you just use your mouse and you bring to the right. That's translate. Or you rescaling. You remember when you crop photo, you make it bigger and smaller. How can the iPhone or your phone is so intelligent to make it the right size? Otherwise, your scaling of your face becomes fatter or thinner. Yeah, this is the scaling. Or you rotate, right? You can always rotate or flip. Or this morning, I just learned how to flip a photo in Edit. Okay, so you can rotate. And then the inside is how you do the translation when you multiply by matrix. Okay, you multiply by like sine and cosine, and it becomes, you can rotate. This is behind how we can do all this. We are the user, but the one behind it, they use all this technology. Okay, I mentioned about cryptography. Okay, they use also matrices. Cryptography is a study of the coding theory. Like long time ago, not long time ago, we used Telegram, right? Telegram to send messages. We don't use WhatsApp. Not the Telegram like WhatsApp. No, like letters. So for example, the message is, attack is tonight, right? So this is how you write, ATTACK attack is TONIGH, 29. So you write according to row, yeah? Then you don't give that. You assign from A to Z, A to Z, you have 26, right? 26. So give A 0, give Z 25. So you put A is 0, B is 1, and so on. So every letter is a number. So instead of A, you put 0. Instead of C, A, B, C, C is 0, 1, 2, C is 2, right? And so on. So what you send is not this. People can still read this, but you send a matrix in the form of numbers. So this is how, if you watch like CSI, right, the crime scene, this is what they do when they don't want the enemy to know. Okay, this is the like FBI, I don't know in Indonesia what you call police. So this is the process of data encryption to be carried out by the help of invertible key. And this key can be generated using matrices. Okay. Now, this is a little bit review of your linear algebra. Yeah. You learn about matrix. I have mentioned about linear equation. You will also learn about vector. Vector, you are done already or not with the vector space? Yeah, and then after that, transformation. And the last one is eigenvalues, eigenvectors, and diagonalization. Okay, linear algebra is my actually most favorite subject. Okay, I mentioned about this linear equation, but you remember, right? How do you solve a linear system and in matrix, right? You just flip row, or you multiply by a scalar, or you do KRI plus RJ, right? You multiply a multiple of one row to another row. I think you have learned this. I'm not going to go into detail. And linear equation, right? This is the linear equation. It doesn't have to be the same, M and N. So you write into matrix. And then you do all the operation, right? From this quite complex equation until the very, very easy identity matrix at the end and give you the answer right away, right? So this is done using matrix. And then when you learn about vector space, maybe you have learned about vector space, the set of matrices is a vector space, not all, but like this is a vector space, yeah? This is a vector space, this is a vector space, this is not a vector space, this is not a vector space. I think you learn this in this. So you see vector space in the form of matrices. This is all mathematics. I mentioned about linear transformation in which some matrix is the rotation. Okay, you multiply a vector by this matrix, you will see what happened. What happened is you rotate 90 degrees. Like 1, 0, 1, 0 becomes 0, 1, 0, 1 becomes negative 1, 0, and then 1, 1 becomes negative 1, 1. Yeah. So this is actually, this matrix is actually a rotation. So this basic information is used by the one before in physics, in chemistry, in computer science. This is the very last thing that in UTM we learn in linear algebra. Very last chapter, chapter 5, is how do you diagonalize a matrix. Diagonalize a matrix means this is a matrix and it becomes diagonal, right? D is diagonal. How can the matrix be diagonalized? And this is the diagonal, right? This is the diagonal. And why do we want to diagonalize a matrix? Because one way is to find the power of a matrix. Say you have a calculator, but sometimes calculator cannot compute what is A to the 10 is still easy. what is like a to the 100 or a to the 1,000, right? If you do diagonalization like this, you can just multiply because the diagonal to the power is just power of the diagonal entry. Okay, that is the fact. Instead of you multiply a 100 times, a times a times a, with this formula, this means you just find the formula, the eigenvalues, eigenvectors. What you have to find is just the d, eigenvalues to the power, that's it, which is the diagonal. Is much, much easier. You will learn about this if you haven't learned this yet. Okay, I'm running short of time, right? But this is the last slide. Okay, you can, if you are interested, you can visit my website. Okay, my website. If you want to write to me, maybe just to say hi, this is my email. Okay, this is my full name, but my initial, yeah. And I also have LinkedIn. I also have my classes, especially during COVID, in YouTube. So I have classes in discrete, I think in some other classes that I during the past 2 years. And again, if you have the opportunity, I don't know, maybe you want to continue your master's or PhD in UTM, you're all very welcome. We have not only mathematics, we have computer science, we have engineering, we have more than 500 Indonesian students in UTM. Used to be close to 1,000, now I think still more than 500 studying in UTM. This is a lake on campus.